Hi, this is a 6-part tutorial series to make a complete platformer game in Gamemaker. The game we're making in this series includes momentum-based movement, wall jumping, and a save load system, and everything else you need to make your own platformer game. The goal is to help you learn about Gamemaker and what you can do in this app with relatively simple code. My name is Dr. Sky, and I'm a professor of digital media arts at the University of St. Thomas in St. Paul, Minnesota. This is part 1. In this video, you will learn how to implement a momentum-based movement system, jumping, collisions, and simple animations. So let's get started. So unlike a more beginner-friendly tutorial, I will try to keep my pace up in this series. I'm going to try to avoid explaining how every line of code or function works. I encourage you to look these things up in the Gamemaker manual to learn about them if I skip over an explanation, excuse me. If you want a simpler tutorial, I encourage you to try my first game tutorial that I should have available to you. Let's start a new project. New blank, project name. I'm going to call this, I don't know, basic platformer 2022. Why not? Let's go. Here's our workspace. So let's create a new sprite for our player. Sprite, create sprite. I'm going to call this sprite s_player. And I encourage you to download the appropriate game assets folder. You should have access to it either in the description of this video or somewhere else that you should have access to it. For instance, I use this in my classes, and so my students should know where to find it. So I know where it's on my computer. There we go. Let's find the sprite for the player. sPlayer 0. There should be 10 images total. Or 6, let's see. There should be 7, there we go. 7 images total labeled from 0 to 6. Open all those. Hit yes. Set the frames per second to 10. I'm going to set the origin to middle center. Let's preview that. Yeah, that looks right. Close that. Let's create an object. Object create. Call it oPlayer. Assign the appropriate sprite. And let's close that. Let's rename our default room to r_level1. Open that up. Drag your player in there under the instances layer. Now let's start coding this. Now we're going to reduce the size of this level really soon. I made this a really small game to be played in browsers, but also because I don't want people stealing my game design. So it's all honestly too small to make with your own projects. It's really only good as a tutorial. So here we go. Add a step event for our player object. Oh. And we will choose GML code every time. GML code. There we go. And in its step event, write get inputs comment key left equals keyboard _ check vk left right keyboard check vk right. So this will give us variables to let us know when these buttons are being pressed. Now write comment get move direction. Now these cautions you can ignore. This just means we haven't declared these variables anyplace else, but we're going to do that in a bit. -1 is left, 1 is right, 0 is nothing. Var local variable dir equals key right minus key left. So if we underscore there, if we're holding down the right key, we will get 1, the number 1. If we hold down the left key, we'll get the number 1. And so 1 minus 1 equals 0 if they're both held down. If they're 0 minus 0, it's 0, so it'll be 0 if neither of them are held down. And if one of them is held down, the key right button will give us +1, and if we hold down the left key, we'll get -1, and that will tell us our direction. +1 to move right, -1 to move left. Now write a comment, get horizontal speed, negative HSP means going left, positive means going right. HSP, which stands for horizontal speed, but we don't write h speed, we use this, our own named variable. Oh, plus equals dir times xl. Now we're going to define xl in a moment too. So with this code, the horizontal speed will be the correct direction, and the xl variable will tell us how fast to increase that speed. In other words, it will keep adding the xl value, meaning accelerate value, until it reaches its max speed, something we're going to write in a bit. Lastly, let's commit the horizontal speed to the object's x position. Commit the HSP to the object's x. Man, I am not typing well. Object's x position. X plus equals HSP. All right, we need to declare some variables in the create event, or also you can declare those variables here under variable definitions. Both are totally acceptable. I like to do it in the create event. Comment speeds, HSP equals 0, horizontal speed variable set to 0, not called hspeed. Player inputs, key left equals 0, key right equals 0, momentum XL equals 0.5, and acceleration variable. All right, let's see if that works here. Everything's declared. Okay, with this, we should be able to move our character. Let's see. It's going to be very small on this monitor. Ah! It accelerates. It doesn't slow down because we didn't add deceleration yet. Oh, it's coming back. There we go. Now we need to tell the game to slow the character down to 0 if the dir value is 0. Meaning neither key is being pressed or both keys are being pressed. So to do that, let's write this code in the step event before we commit the horizontal speed to the object's x position. If dir double equals sign 0, to check if it's 0, let's see, slow down character if no direction key is pressed. This a little bigger. Oh, I'm going to open the curly bracket here. I'm going to start doing inline open curly brackets in this project. If HSP is less than 0, open curly bracket, close curly bracket, meaning going left, HSP equals min, which is a cool function. It finds the smaller of the two whatever values you put in the parentheses. HSP plus decel or 0, whichever is smaller, assign HSP to that. Else, open curly bracket, close curly bracket, HSP equals max HSP minus decel or 0, whichever is bigger. So if we're going left, we want, meaning our HSP is negative, we want to gradually increase that number until we get to 0, and this is what this does. And if we're going to the right, which means our HSP is positive, we want to gradually decrease it. We want to decelerate it until we get to 0. So let's set the max speed, or we're going to clamp it. We're going to use a cool function called clamp to make sure this value, this variable doesn't get above or below certain numbers. Clamp this variable to negative max HSP, and max HSP. Set the max speed. Negative because we're, again, HSP that's negative is going to the left. HSP that's going to the right is positive, so we want to clamp it to those values. So we got to declare these variables in the create event. Under speeds, let's write max HSP equals, I don't know, let's try 3. A maximum horizontal speed variable set to 3. And under momentum, we will write decel equals 0.3 deceleration variable. So before running the game, let's go into game settings and make sure that we're running at 60 game frames per second, which we are. So let's test the game now. We should have a max speed so our character doesn't go flying off, and there should be a very, very short acceleration period and deceleration period when you press and let go of the movement keys. I know you can barely see that character on the screen because I have a large monitor. There we go. Let's add blocks for collisions, gravity, and some jumping now. So let's create a sprite for our block, which is going to be the thing we can jump on. Create sprite s underscore block, I guess. Keep it to my naming convention. Let's make it a solid color, and let's make it 32 pixels by 32 pixels wide. Edit image, make some solid color here. About, yeah, there we go. That's a good color. Should we set it to middle center? Yeah. Let's keep it to the top left for now. That makes it easier to paint into the room. We can always change it later. I like the origin for most of my sprites to be middle center, but some objects like collision blocks, we can set it to the top left so it snaps right to these intervals at the grid. So this is our room. We want to make sure our room grid is set to, our layer grid is set to 32 by 32 pixels, which is the same size as our block. Under instances layer, oh, we need to create an object for it. Create object. Oh, block. Before we put it in the room, we need to make it an object. Assign the sprite. There we go. And let's resize the room to make it an interval of 32 pixels, both horizontally and vertically. So I'm going to make mine 640 by 512. Like I said, this is going to be a very small game. Get my character back in here. And let's select the block, hold the Alt or Option key, and let's paint it in. If I can. There we go. Blocks all the way around, like those. One thing I like to do with collision blocks is that I like to make sure I can see where they begin and end. So let's add a quick, let's do a line. There we go. A little quick X over here so I can see where the edges of this block are. There we go. That's a little bit nicer. See where my collision blocks are. And I didn't mess with anything too important. No. All right, let's drag these blocks around a little bit more and make like a little area that our character can jump around in. There we go. that too high? That might be too high for our character. There we go. Let our character jump around a little bit. All right, let's add some collision code to this game. Let's open up our player object in the step event. So before we commit to this movement right here, we should check to make sure we can move there. So we're going to add this before this x plus equals HSP. So let's add our horizontal collision. If place meeting x plus HSP, y whole block, and double end parentheses, open curly bracket, close curly bracket, var 1 pixel equals sign of HSP, while place meeting x plus 1 pixel y o block x plus equal 1 pixel, HSP equals 0. Did I do anything? There we go. Yeah, so nothing crazy here. You'll see this kind of collision code in a lot of different tutorials, including my more basic tutorials. But basically, we check which direction we're going, and we get that direction by doing sign. If it's a positive one, it means we're going to the right. Negative one means we're going to the left. And then we check to see if we're about to move into the block. And if we are, we don't move. And instead, this while loop inches us 1 pixel at a time until we touch the block. And it all happens within one frame. And then we set our horizontal movement speed to 0. And then we commit to this movement. Let's see if this, yep, our character is stopping there and there. Okay, now we can't move up and down yet. We're going to do that in a moment. So let's copy and paste this entire section and just rename it vertical collision. And then just change things here. Y plus VSP. Now we haven't done anything with vertical movement yet, but we will in a bit. So let's just preempt this. Vertical speed VSP here. Remove this 1 pixel code and move it over to the Y. Change this to Y and then call this VSP. Call this Y and call this VSP. And in the create event, where we declare HSP, let's declare VSP equals 0. Now we won't notice a difference because we haven't added any vertical movement code yet. But whenever we add new code, we should always run the game to make sure we haven't introduced any bugs. Now everything should work exactly the same, which it does. Okay, let's add some vertical movement code. All right, so let's add a comment before we have the code that calculates the horizontal movement and comment it as calculate horizontal movement. Calculate horizontal movement. And then right after that, before the collision code, we can have a section called calculate vertical movement. And in that section, we'll add some gravity. So let's write VSP plus equals grav for gravity. That way we're always going to be moving down towards the ground. In the create event, we can declare our grav variable to equal something like 0.4. And check to see if it works. Our character should fall down. Whoop. And down and down. Good. Let's add a quick restart command so we can quickly restart the game to more quickly test things. At the very bottom of the step event, add some code, call it quick restart game. If keyboard check pressed, VK enter, game restart. So we can hit the enter key and restart the game quickly. So we fall down, good. We can move nicely. Collisions are working. Excellent. Now let's add jumping. In the get input section up here up top, let's add a few more keys. Key jump equals keyboard check pressed, VK up, which is just pressed means that it just checks the last frame that button was pressed, so it's just like a single click of the key. And then also key jump held equals keyboard check. Just regular keyboard check, and also do it VK up, the up arrow key. Let's go to the create event, declare those variables right here. Key jump equals 0, key jump held equals 0. So to make sure we can only jump if we're touching the floor, we need to add the following to the calculate vertical movement section. Ground jump. If jump buffer is greater than 0, open curly bracket, close curly bracket, but let's add a comment here. Check if the jump buffer is greater than 0. If it's greater than 0, jump buffer minus minus, which means it's just going to reduce by 1 every frame of the game. You could also write that as minus equals 1, right? A little quicker just to do minus minus. Reduces jump buffer variable by 1 each step. If key jump, open curly bracket, close curly bracket, let's add a comment. Check if jump key was pressed. Jump buffer equals 0. It resets our jump buffer. Set jump buffer to 0. Can't jump again. VSP equals jump speed. Jump up. So this just makes it that you can't perpetually jump in the air. That it makes it so if you jump, jump buffer gets set to 0, and if it is 0, you can't jump again. Jump buffer has to be above 0 in order to get access to this code. So at the end of the step event, we're going to declare this variable in a moment, but we can get to that in a second. At the end of the step event, add a section called, like before the restart game control section, we'll say calculate current status on ground equals place meeting x y plus ground buffer o block. If on ground is true, jump buffer equals 10. So whenever our character is on the ground, jump buffer will be perpetually set to 10, which means it's above 0. And then when we jump in the air, jump buffer gets changed to 0, and we can't jump again. And if it's above 0, it is always reducing itself by 1 if we're like in the air, like falling or something. So basically it lets us know if we're on the ground or not, and it gives us a jump buffer, which is just a way of letting the player jump for a few frames after they left the ground. It just feels better. Some people call that coyote time, me referencing the coyote from the old Looney Tunes cartoons, where you can run off of the side of a platform and begin to fall, and you're not touching the ground, but you can still jump for a few frames. So that gives us just 10 frames in which we're able to jump even though we're falling from a platform. Perfection is the opposite of good game design, so we like to add these little buffers to make the gameplay experience feel more organic. Also, by adding the ground buffer code here, y plus ground buffer, the place meeting, instead of just +1. I mean, we could check if we're on the ground just by saying like, hey, whatever we're at, just take the vertical position, add 1 pixel, and does that collide with the ground? We could just do +1, but we add the ground buffer to give us some flexibility so that you don't exactly have to be touching the ground to jump. You can just be close to the ground, whatever we set the ground buffer to be, like 3 frames or 2 frames, not frames, 2 pixels, 3 pixels. That makes it if you're jumping in quick succession, sometimes you'll feel like you were touching the ground and you're like, hey, why didn't my character jump when they weren't technically touching the ground? But again, this just makes it feel more organic, and almost any modern platformer has a jump buffer and a ground buffer to make it feel better. We got to declare these variables in the create event. So let's create a new section called jumping. On ground equals false. Boolean variable to see if we are this. Oh, I need a comment. Boolean to see if we are on the ground. Ground buffer equals 3. Allows us to jump if we are at least 3 pixels close to the ground. Jump speed equals -8. A jump height number. More negative the higher the jump, because moving up in Gamemaker is negative, moving down is positive, because the room coordinates start at 0 at the top of the room. And then jump buffer equals 10 frames after leaving ground when we can still jump. Let's check to see if it works. I can jump. Oh, jump, jump, jump. Now you notice I can start falling and still jump. Now you could reduce the jump buffer to make it smaller if you feel like that's inorganic, but I like to be very flexible with the jump buffer. But if you wait too long, can't. And also notice that we don't have a variable jump, which means when we press the jump button, we only get 1 jump height. We're going to do some code where we can just barely tap the jump to go a smaller jump height and then hold the jump button to jump higher, like most platforming games. So let's go to the ground jump code, and we're going to add this line, which is going to give us variable jumps. If VSP is less than 0, meaning we're moving up, and if key jump held is false or zero, open curly bracket, close curly bracket. Let's add some comments. If going up and not holding jump key, VSP equals max, VSP -3, whatever is smaller, or whatever is bigger, set VSP to higher, smaller jump number. So if we're not holding the jump key, we are going to jump significantly lower. The smallest amount we can jump is -3. And let's add a cap to how far we can fast, as well as how fast we can jump or rise, like we did with horizontal movement. So let's VSP equals clamp. VSP, we're going to clamp it to max VSP and negative max VSP and max VSP. And we got to declare max VSP in the create event under speeds. Max VSP equals 10. Note that if you ever want your jump height to be bigger than -8, say you want to set this to -12, that would be bigger than our max VSP amount set here, negative max VSP, and so your character would never be able to jump higher than, say, with a bigger amount than -10. So you would need to adjust max VSP or have different values for jumping versus falling. You could have, say, max VSP jumping and put that here instead. If you want to be able to jump higher or faster than you can fall. But this adds a cap so we're not like perpetually accelerating when we're falling down. Let's see if it works. We should get a variable jump now. So if I barely tap on the key, I get a really small jump. But if I hold the jump key, I get a taller jump, smaller jump, taller jump. This allows for more precise movement. Say you're just trying to hop between blocks without jumping too far. You can sort of tap it, but if you need to jump farther, you can hold it. There we go. And ground buffer is working too because I'm tapping on it right before the character touches the ground, barely, and it's nice and not precise, which feels good. Let's add some player animations. I have all these sprites created. Let's import them. Let's import some sprites. So under sprites, let's create sprite s_player run. And let's import the appropriate images. So player run. There we go. Player run. There's 12 images going from 0 to 11. Import all of those. Hit yes. Let's set the animation speed to 30 and be sure to set the origin to middle center. For all of our player object sprites, we're going to set them to middle center because I created their size to be very precise and also they match regardless. And yeah, let's close that. Next sprite, create sprite s_player air. Import the appropriate images. There should be 2 labeled 0 and 1. And we don't have to worry about animation speed. We just need to make sure that this sprite is the first one and this sprite is the second one. This is for rising up in the air and this is for falling. Let's set the origin to middle center as well. So this next step is really important. We need a uniform collision mask for all of our player character sprites because our object is going to be changing sprites between these different sprites that we just imported, but we want to make sure that no matter what sprite we're using, the collision mask or the part of the sprite that bumps up against the block is always the same. And in Gamemaker, it's really easy. Just go to O player, and where it says collision mask, instead of same as sprite, we just make sure it's set to S player. That means that if this sprite gets changed to S player run or S player air, the collision mask will always be the same as S player. Boom. And actually, let's go to S player and check out the collision mask. And that looks good right there. That is an appropriate collision mask. We don't have to change it. Now we need to tell the game when to use these different sprites. So we're going to create a new section in the step event of OPlayer at the end called adjust sprite. Let's put it underneath the calculate current status, adjust sprite. Image speed equals 1. Semicolon. 100% of animation speed. If moving, orient sprite according to direction of movement. Because our running animation is only set to one direction, we'll want to flip it on its x-axis if we're moving to the left. So we will write if HSP does not equal 0, meaning we are moving any direction, image x scale equals sine HSP. Now remember, we use sine HSP for our collision code, which just tells us, hey, if we're going to the right, set this to +1, and if we're going to the left, set it to -1, and that will flip the image x scale to be facing its normal direction or reverse it to -1, which is facing to the left. If not on ground, or if on ground is false, open curly bracket, close curly bracket. sprite index, let's change the sprite, equals S player air. So if we're not on the ground, meaning we're in the air, we need to change it to the correct sprite, which we just did right here. Let's set the image speed so it's not animated, because that is one sprite that we don't want to be flipping between those two frames. We just want to set it to one frame or the other frame. So stop animation speed, make a still image. Image index equals, hold on, sprite index. I misspelled that. Oh, that's why I was getting that little caution. Now this. Image index, meaning which frame of the sprite, equals VSP greater than 0. So what this does is that it looks for the statement within these parentheses, and if this is true, it'll return 1, and if it's not true, it will return 0. And if you remember with these frames, this is frame 0, this is frame 1. 0, 1, 0, 1. So what we want is if the character is falling, meaning their VSP is above 0, it's positive, the character's moving down, we want the second frame, which is frame 1. And if we're going upwards, which means the VSP is negative, this becomes not true. So this returns as a statement as 0 to image index. So a cool little programming trick. Write something as a statement and it will return either 1 or 0 in Gamemaker language. Next, after this, else. Open curly bracket, close curly bracket. And what is this? This means if on the ground. If HSP does not equal 0, open curly bracket, close curly bracket, let's add a comment. If moving left or right, sprite index equals S player run. Add else here. Else, open curly bracket, close curly bracket. Let's add a comment. Standing still, sprite index equals S player. It's our regular standing animated breathing player sprite. And that is enough for animation. Let's run the game to test it out, see if we have any bugs. So our character is doing that sort of breathing animation, which is good. And we have the running animation that orients the character appropriately. We have the rising animation and the falling animation correct. Beautiful. And when we stop moving, it just returns to our typical player sprite. Beautiful, beautiful, beautiful. All right, that's it for our basic movement. Now, in future videos, we're going to do like wall jumping, enemies, a weapon system, checkpoints, save load system, combat. We're going to be doing a lot of things, a menu system, transition system, but this gets you basically to what a platformer is in terms of basic game mechanics, is just moving and jumping. I'm excited to teach you how to do other things in this series, so stay tuned and good luck.